Let's go straight into analyzing the third quarter of the board. First, if you didn't watch the previous two videos where I go over the first two quarters of the board, you really should watch them, otherwise this may not make much sense to you. Okay, this is similar to our first top quarter, except now we start each move at the row with index 7. Instead, the first quarter we started from the top with index 0. But unlike the first quarter, we are moving in such a way that both the rows and columns are decreasing. So you can see we start from the row 7 and move to the row 0, and we start from the column 7 and move to the column 0 as well. So again, we make the outer loop to loop through the columns instead of rows, and the inner loop will loop through the rows instead of column, which would be the usual way the nested loops work. And again, that's because the inner loop always starts from 7, which is our starting position for the row. And the outer loop is quite typical. We start from column 7 until column is greater than 0. So we go from 7 to 1. We ignore 0 because that's just one single square, and you cannot go diagonally from there in the same direction as the others are. Now the inner loop also starts from 7, which is the index of the row 7, and decreases by 1 because we move from row 7, then we go to 6, then we go to 5, and so forth. However, the number of iterations is 7 minus column. And that's because the column changes by 1, and you can see that each diagonal is 1 square shorter than the previous one. So at the beginning, the inner loop is simply going 7 minus 7, because the column is 7. So it goes from index 7 for the row to 0, which is correct. We go to the row 0. After we move to the next diagonal, column is now 6, because we decrease it in the outer loop. So the number of iteration now is from 7, which is the row, minus 6, which is 1. So we go from 7 to row number 1, which is where the second iteration ends. The next one would be 7 minus 5, so we'll end in row 2, which is the third iteration, and so forth. And finally, the indexes for the board are the same as in our previous quarter. The difference is that in previous quarter we always started from column 7, and in this time we start from row 7. So we just kind of reverse the indexes. But if you look at them, then you notice that first we start at column 7 for the outer loop, and the row starts at 7. So our column over here will be 7 plus 7 minus 7, which is of course 7. So we have 7, 7, which is the bottom square. The next iteration of the inner loop, row now equals 6, so we change the index for the row to 6, which is here, and the column will be column, which is still 7, because we're still in the inner loop, plus 6 minus 7, which of course equals 6, so we move to column 6. The next one, the row is 5, so we move to column 5 as well, because column is still 7, plus 5 minus 7 is 5. But then the column is decreased by 1, so column now equals 6. The row starts at 7, so we have our row 7 and column 6, our starting position, and we move diagonally. So in the next iteration, the row is 6, and the column is still 6 as well from the previous iteration of the outer loop. So we have now 6 plus 6 minus 7, which is 5. So now we are in column 5. Then we have 6 plus 5 minus 7, which of course gives us column 4, and so forth. Alright, so let's put it into code. And again, we reset the queen counter to 0, and then we start the loop. And it is exactly as you saw on the slide. And inside the loop, we check if the square is not empty one, just like we did before in the previous two quarters. And if it isn't, we simply add the queen to the counter and run the counter check to see if another queen was already entered into the counter, meaning if another queen was already found on that diagonal. And if so, we return false, and our count queens method resets everything for the next attempt. And of course, after each diagonal, that passed the check, we reset the counter to 0, so we can then check the next diagonal. Alright, we are ready to finish analyzing the diagonals, so let's just do the last quarter of the board. And it's the same principle. This is similar to the right quarter when we were starting every iteration from column 7. Now we are starting obviously from column 0. Our rows are changing the starting position, so they will be our outer loop, and since we start from the last row with index 7 and move to the row index 0, we will be decreasing the row numbers. However, our columns will be increasing because we always start at column 0 and then move forward. So in our inner loop, we start from 0, we loop the same number of times as we have rows. So first we start from 0 to 7, then the row index is decreased to 6, so we loop from 0 to 6, then 0 to 5, etc. And our board index is calculated in a simple way. The column simply reflects the iteration counter for the columns. We start from 0 and we increase by 1 until we reach the limit. So that's fairly straightforward, we just have the column as an index. And the row index is row minus column, and that's because we are decreasing the number of rows by 1. So first we start at row 7, column 0, so 7 minus 0 is row 7. As you can see, that's where we start. The next row is still 7, but column is now 1, so 7 minus 1 is 6. So we move to the row 6. Then 7 minus 2, which is 5, so we go to the row 5, etc. And after the row is decreased in the outer loop, it is now 6, so we calculate 6 minus 0, so we start at row 6. That's the next iterations, the starting position for the row, and the column, of course, is at 0. Of course, the next one, after the outer loop runs again, then we have 6 minus 1, which gives us row number 5 and column 0 and so forth. Alright, so let's put it into code. And this is exactly as you saw on the slide. And once again, we check if the square doesn't contain empty square, and if it not, meaning it has a queen on it, we increase the counter and check if there is another queen in diagonal. And if so, we return false. And if not, then the diagonal contains 0 or 1 queen only, so we reset the counter and move to the next diagonal. Alright, so that's all the 4 quarters of the board. So if we make it all the way to the end of the 4th quarter loop, we know we have queens positioned correctly without any queen attacking any other queen, and we can return true. Alright, we're almost finished. We will put it all together in the next video, and we will test if everything is working as expected. Thanks for watching.